problems. First of all, let's get this straight. When you see the word per, divide. When you see the word of, multiply. Here's a hen problem. If 3 hens lay 4 eggs in 5 days, how many days will it take a dozen hens to lay 8 dozen eggs? These 3 things determine the rate of the problem. Once we know the rate, we apply it to the second part of the problem. I don't want to know hens per egg. That's kind of weird. I want to know eggs per hen per day. So I'm going to do 4 eggs per 3 hens first and find a rate for that. So when I say per, that changes into a unit rate that will be how many eggs per 1 hen, okay, if I divide. But I don't really want to divide out 4/3 and make a messy decimal, so I'm just going to keep it as the number 4/3. So 4/3 eggs per hen, but that still is 5 days. So now I'm going to divide it again by the 5 days to get a unit rate for that also. Now dividing 4/3 by 5 is the same as multiplying 4/3 times the reciprocal. And so that is 4/15. That is my rate for the number of eggs laid by 1 hen in 1 day. Now I can use that rate to solve the problem. Well, the first thing I see is that it isn't 1 hen, it's a dozen hens. So you can actually multiply the rate by 12 to change it to a rate for a dozen hens. So 4/15 eggs times 12 hens equals, well, before you multiply that out, I love to reduce. Let's divide by 3. 16/5 is still eggs, but it's eggs laid by 12 hens now, every day. Okay? Now, if I had a number of days, I could multiply by that also. But in this problem, I don't know the number of days, so I'm kind of working backwards here. I know the number of eggs I'm aiming for, 8 dozen. That's 8 times 12, right? So if I want to know how many days it takes, if this is happening every single day, I want to know how many units like this go into 96. That's division. So we're doing 96 divided by 16/5, which is the same as 96 times 5/16. I see some reducing again. I know 8 goes into both of those. They're both even, so 2 also goes into both of those. And what's left is 6 times 5 is 30. It takes 30 days for those 12 chickens to lay 96 eggs. Let's have a train problem. You gotta have a train problem. First of all, general distance formula, so important in algebra. Distance is always equal to the rate times the time. Rates are all going to be things like miles per hour, feet per second, things like that. If a train leaves a station at 1 p.m., it travels at an average rate of 60 miles per hour. So train number 1 leaves at 1 p.m. and it's traveling 60 miles per hour. Train number 2 leaves the same station an hour later and it travels 96 miles per hour. Okay, the second train follows the same route as the first train on a track parallel to the first. In how many hours? So that tells us, when you look back at the formula, which of these has to do with hours? That will be time, so time is missing. In how many hours will the second train catch up with the first train? The only way the 2 trains can catch up is if their 2 distances are equal. So that's the key to what we're going to do right now, is somehow we're going to find the distance for the first train, the distance for the second train, and set them equal. They will have a variable of t in them, and we'll solve for t. Let's see what we've got. We have the rate taken care of. We need time. Well, let's let the first train's time be t hours. The second train is always going to be 1 hour less because it started an hour later. So that's t minus 1 hours. And distance, we can use the formula for. Keep in mind what our formula says. It says distance is rate times time. So the distance for the first train must be 60 times t. And the distance for the second train must be 96 times t minus 1. And remember, we want them to catch up, so we're going to set those equal to each other. So we're going to say that 60t has to be equal to 96 times t minus 1. The reason we do this is we are forcing them to be equal and then solving for the amount of time that will make that true. There's only one solution to this problem, and it's the exact number of hours that makes the trains catch up. I need to keep this for one more row, but I'm going to distribute on this side. Let's get those t's together. Subtract 96t. Okay, let's get t by itself by dividing. And that is what t is. So this is the number of hours. Well, we can simplify that, right? First of all, a negative divided by a negative is positive. 96 divided by 36 is 2 hours with a remainder of 24/36 of an hour, which reduces, if you divide by 12, to 2/3 of an hour, which is the same as 2 hours and 40 minutes. Okay, remember this is t. So that is the time that the first train traveled. And the second train traveled 1 hour less because it's so speedy. So if you subtract 1 hour, we find that the second train needed 1 hour and 40 minutes to catch up with the first train. So these rate problems are a little more challenging. I hope you can have some fun with problems like that.